Lesson 7.2, third part of the lesson, day 3. The learning target for this lesson is for you to be able to solve for the intersection points of a line when it intersects the circle, or find out when it doesn't intersect if there is no intersection point, or to find the single point if there is a point of tangency. Recall from when we did polynomial functions that we could have a graph that intersects the x-axis, or it could touch and bounce. And when it touches and bounces, that is said to be a point of tangency. To intersect is to cross over. To touch, but not cross over, is to be tangent. So we see when we look at this circle and this linear equation, here's an example we'll do numerically in a second. We have the line intersecting the circle at 2 points. So we'd need to find those 2 intersection points. This, we have a tangent line. The line is tangent to the circle because it does not cross over into the circle. It just touches on the circle and then continues extending, but doesn't cross into. This line is actually called a secant line, but it has 2 intersection points. This has a point of tangency. Would be a phrase that you learned in geometry. And figure 3 is where the line and the center, or the circle, we have the equation of the circle and the equation of the line, and we find that they actually don't intersect. So let's look at each of these examples. Find the coordinates of the points, or point, where the line intersects the circle. So for this one, it's going to be like figure 1, I know this because I've already worked it out, that it's going to have 2 intersection points. This will be an example where it will only have a point of tangency, and this will be an example that matches figure 3, where there is no solution. Now, graphing a circle and then graphing these linear equations in the same coordinate plane isn't going to be so easy for you right now, and we're going to be required to do this algebraically. So we're going to work on the algebra aspect of it. So here it is. I take this and I think I'm going to choose to solve for y, but you could just as easily solve for x. So I have a linear equation in terms of y equals 6 minus x, or negative 6 plus x. I'm going to take this and plug it in where I see y. This becomes x minus 1 quantity squared plus 6 minus x minus 4 becomes 2 minus x squared equals 25. So all I've done is plug this in place of y, and the minus 4 was there. So I had 6 minus 4 is 2, and still the minus x. Now I need to FOIL, or distribute, x minus 1 by x minus 1 plus 2 minus x by 2 minus x equals 25. To try to get this so that it's, right now what's nice is it's all in terms of x's, and I see the highest degree is 2. I have a quadratic function. When I've substituted this in, I now have a quadratic function. To solve a quadratic, we have to have it in standard form and get it equal to 0. So I'm going to FOIL this. This gives me x squared minus 2x plus 1. This gives me 4 minus 4x plus x squared. And we still have a 25 over there. I haven't added or subtracted anything to both sides. I just actually performed the squaring by FOILing. When I combine like terms, I have 2x squared minus 6x plus 5 equals 25. And we're going to get this equal to 0 by subtracting 25 from both sides. So now I have 2x squared minus 6x minus 20 equals 0. I'm going to do the greatest common factor of 2, leaving me with x squared minus 3x minus 10 equals 0. This quadratic is factorable. The factors are x minus 5 by x plus 2. That means that my possible answers for x, if I were actually looking at the graph of the circle and the graph of the linear equation, would be x equals 5 and x equals negative 2 would be the intersection point. This would be the negative 2, this would be the 5. I don't know if that's the exact graph or not, because this one has a negative slope, so it would look a little different. Now I'm going to plug these in to my linear equation would be easiest. You could plug them in here and solve for y if you want, but then you'll have to solve another quadratic. I'm going to plug them into the linear equation. 6 minus 5 is 1. 6 minus negative 2 is 8. So my ordered pairs for the intersection points are 5, 1, and negative 2, 8. There are 2 points of intersection right there. And here's my algebraic evidence to show how I found the values of x. In this next example, they already have the linear equation solved for y, so we're going to leave it like that, and I'm going to replace y with this. When I do that, that means I'll have, inside that parentheses, I'll have 2x minus 13 minus 5 squared, which will be 2x minus 18. So I have x minus 4 times x minus 4 plus 2x minus 18 by 2x minus 18 equal to 20 when I expand this. In multiplying this out, I have x squared plus or minus 8x plus 16. In multiplying this out, I have 4x squared. 2 times 18 is 36 times 2 is 72, so I have negative 72x. 18 squared is 324. And that equals 20. When I combine like terms, I have 5x squared minus 80x. 16 plus 324 is 340, but I'm going to subtract 20 from both sides to get it equal to 0. 340 minus 20 is 320. All of these are divisible by 5. So I'm going to take off the greatest, or take factor out of 5. I'm left with x squared minus 16x plus 64. This one is also factorable. If it weren't factorable, I would use the quadratic formula, but it is factorable. The factors are x minus 8 by x minus 8, multiplying to 64, adding to negative 16. This gives me 1, 0 of x equals 8 with multiplicity of 2. Well, think back to our graphs. When we had even multiplicity, we had a bounce, right, on that function. But I'm actually looking for an intersection point, so it's still going to be a tangency, though, because I only have one place where it intersects. Plugging it back in, I have 2 times 8 minus 13. That's 16 minus 13, which is 3. So my point of tangency, the other ones were intersection points, but my point of tangency is 8, 3 for this problem. Our last example of this particular skill, where we're given the equation of a line and a circle. It could be an ellipse, but in this case a circle. We take this, I'm going to solve for y by subtracting 2x from both sides. So I have negative 2x plus 5. I am going to plug that in for y. You could just as easily solve for x and plug it in for x, but I'm not choosing to do that for this. So when I do that, I'm going to have this plus 3 also. So that's going to be x plus 1 squared is x plus 1 by x plus 1, plus, this is going to be negative 2x plus 8. So negative 2x plus 8 by negative 2x plus 8, and that equals 4. This product is easy. It's x squared plus 2x plus 1. This product is not too bad. Negative 2x and negative 2x is positive 4x squared. 8 and negative 2 is negative 16, but negative 16 and negative 16 is negative 32x. 8 and 8 is 64. Now I'm going to combine like terms. This is going to give me 5x squared minus 30x plus 65 equals 4. I'm going to take 4 away from both sides to get it equal to 0. 5x squared minus 30x plus 61. Well, it's not factorable. That doesn't mean that there's not a solution, because we could have an irrational solution that's still a real solution. But I can't think of the factors, so I'm going to turn to quadratic formula. And when I do, I have the opposite of b over 2a plus or minus the square root. Our discriminant would be 30 squared, or negative 30 squared will be positive 900, minus 4 times 5 times 61 is negative 320. Well, this is going to have an imaginary answer. And while sometimes I'm very interested to know what it is, I'm looking to see when the circle and this line will intersect. And the solution I'm getting is imaginary. So that means that there is no real, since there's no real solution to this, the circle and the line will not intersect. There are the three cases that you might see. Once again, I could have just as easily solved for x here, had x equals 6 minus y, and plugged that in here. Sometimes that's a little more convenient to solve for y first. Our second skill for day 3 is to be able to write the equation of a line. You may or may not have done this in geometry. What if you were given any 3 points on a circle? Could you find the equation of the circle? This would have made a lot more sense in geometry if you had had strong algebra skills. Not everyone does. That's why we don't always cover this skill in geometry, because you guys are all already pummeled with so many circle theorems and formulas and equations and product rules and product secant segment rules with sums and products. It gets a little crazy. But there is a theorem that says that the center of a circle, right now we've got these 3 points, they form a triangle. The definition of what's called the circumcenter is that if you take the points of a triangle and you find the midpoint and the perpendicular line, so a perpendicular bisector to each one of those, you would get the center of the circle. You would, if I did a perpendicular bisector to this line and a perpendicular bisector to this line and a perpendicular bisector to this line, it would give me the center of a circle that would circumscribe the triangle, or enclose the triangle in a circle. To find the circumcenter, we need to find and solve the system of equations of the perpendicular bisectors for the 3 sides. Technically, you could do this for 2 and then just check it with a third. So I'm going to call this point A and this point B and this point C. I need to write the equation of a perpendicular bisector for line AB, and I'm going to do it also for line BC. And if I have those equations, I can solve the system of equations for where those 2 lines intersect. And that will tell me where the exact center of the circle would be if I just have 3 points that are on that circle. To be a perpendicular bisector, we need the midpoint. The midpoint formula, to review, is adding the x's and dividing by 2, adding the y's and dividing by 2. It's the average of the x's and average of the y's. That'll give us the bisector part. To get the perpendicular part, we first need to know the slope of AB, but I don't want the slope of AB if this were AB. I'd want the slope that's perpendicular to it. So I would then get the perpendicular slope by doing the opposite reciprocal. So if the slope of AB was R over S, then the perpendicular slope would be the opposite of S over R. It is the opposite sign, this was positive, this one's negative, reciprocal fraction, opposite reciprocal, something you did a ton in geometry. You also did some of this in Algebra 1, or should have. So I'm going to start by finding the midpoints of AB and BC. So my midpoint for AB is going to be negative 12 plus 19 over 2, and 28 plus negative 3 over 2. I'm going to get my calculator because I don't want to make any calculation errors that would screw me up. So this is, oh joy, 7 halves. 28 minus 3 is 25, so that's 25 halves. That's no fun. And then for BC, the midpoint would be 19 plus 19 over 2 is going to be 19. Negative 3 plus 11 is going to be 8 over 2 is going to be 4. So following the formula, I added the x's and divided by 2, added the y's and divided by 2. I'm averaging the x's and averaging the y's. I now have the midpoint. I need the slope as well. So my slope of AB is -3 minus 28. I do the second minus the first. 19 minus -12. You do first minus second as long as you're consistent on doing the same thing to the bottom that you do in the top, the same order. This is going to give me -31 over, this becomes 19 plus 12 over 31. Well, at least our slope is nice. It's -1 over 1. If that's the slope of AB, then the perpendicular slope is the opposite reciprocal. Well, the opposite of -1 is +1, and the reciprocal of 1 is still 1. So there's our slope. We're going to build our equation with this point and this slope. I'm going to get the slope for the other line for BC now. I have 11 minus -3, which really becomes plus, that's 14. And 19 minus 19, oh crud, that stinks. That's going to be 0. Well, if I have a slope of 0, that's an undefined slope, which means it's to a horizontal line. But if I want the perpendicular slope, then that's going to be a vertical line, or wait, that's undefined as a vertical line. I'm sorry. I want the perpendicular slope, that's going to be for a horizontal line, which is going to be a slope of 0. That's the one exception where it's not opposite reciprocals. It's just, you've got to know that vertical lines have an undefined slope. Horizontal lines have a slope of 0 from Algebra 1. So I have a slope of 0. I'm going to take these equations and put them in point slope form to start. Point slope form, for those of you who don't remember, is y minus y sub 1 equals the slope times x minus x sub 1. But I don't want to use the first point, and I don't want to use the slope of the line. I'm going to use my midpoint to fill in these two values and my perpendicular slope. You did this in geometry, but it's been a while. So I have y minus 25 halves, yikes, that's going to be fun, equals 1, that's not so bad, by x minus 7 halves. There's the equation for the perpendicular bisector to segment AB. If this were AB, this would be the equation of its line, but it's in point slope form. I'm going to do the same thing over here, and then we'll solve to get them in slope intercept form. So I have y minus 4 equals the slope of 0 times x minus 19. Well, this one's going to end up being real easy, because when I multiply by 0, I'm just going to have y minus 4 equals 0. But normally I'd distribute this slope in and then add 4 to both sides. So this is really y equals 4 for the perpendicular bisector to segment BC. And this one, well, I'm going to distribute the 1. Still going to give me x minus 7 halves. And to get y by itself, I'm going to add 25 halves. X minus, okay, so -7 halves plus 25 halves, 25 minus 7 is 18. So this is minus 18 halves. This is y equals x minus 9. I now have my two equations. Normally I would do elimination or substitution. This one, though, because the x disappeared with the slope of 0, becomes extremely easy, because here I have my equations, y equals 4 and y equals x minus 9, set up perfectly for substitution, but I'm just going to take this 4 and plug it in where I see y. Add my 9 to both sides, I now get x equals 13. So I now know the x coordinate of the center of a circle that would go through these 3 points is x equals 13. To find the y coordinate, well, we already know it, but if we didn't, I'd plug it back in. 13 minus 9 is 4. So the center of this circle is 13, 4, and I could easily find its radius by using one of these points with this and doing the distance formula. It does want me to do that. I did not leave you enough room. I apologize. You're going to need another sheet of paper. So it did ask me to write the equation for the circle. Well, there is the center. So this is easy in terms of x minus 13 squared plus y minus 4 quantity squared equals the radius squared. If you want to find out what the radius squared is, take any one of these points now that we kind of have the general equation given the center, and plug them in for x and y. Negative 12 minus 13 squared plus 28 minus 4 squared equals r squared. Well, that's going to be 25, which squared is 625. That's going to be 24, which squared is 576. And 576 plus 625 is 1201 for the square of the radius. This means that our equation is all of this, except in place of r squared, I have the 1201. So I have x minus 13 quantity squared plus y minus 4 quantity squared equals 1201. I'm going to ask you to attempt some of these problems in class when you're working, and we will go over them in detail when I am there to help you with a couple more of those with practice. But these are the general steps. This is like the worst problem with circles. Circles are easy. Circles are way easier than ellipses, way easier than hyperbolas, until we get to this. This is the most complicated thing we do with circles. We can solve for the intersection or tangent point of a linear equation and a circle using their equations. We can find the center of the circle by first building perpendicular bisector equations. Take 2 points, find their midpoint, slope, and opposite reciprocal slope to build the equation. That was this one. Take the midpoint, slope, opposite reciprocal slope to build the equation, and then solve the system of equations. We have our center for our circle. Take that center, plug it into the formula for a circle, plug in one of the other points to get your r squared value, and you get your equation for your circle. This concludes the video notes for the last 2 learning targets of Lesson 7-2. Have a great day.